Okay, looking at number 5 here, I have a benzene with a bromine in it, and I want to turn that benzene into something that has 3 carbons with an OH on the end. All right, seeing the 3 carbons, I need to do something with organometallics, because I need to do a coupling, and it is 3 carbons. One I could have possibly done with a nitrile, but 3 I'm going to be doing something with an organometallic. All right, now thinking maybe this will help eliminate certain pathways. Maybe I can't make an organocuprate out of this. Maybe it has to be attacked. But if I go back to our textbook, I see that an R group, like the benzene, can be the organocuprate or the alkyl halide. All right, so knowing that, I'm going to try to make it work as either. So I'm going to try one method with it as a turn this into a organometallic. And I'm going to do a Gilman reagent because that works a little bit better in the long range. So I got lithium followed up with the copper iodine, and this is where we end up making that benzene that's kind of still branched. I put it in parentheses with a 2 and the copper Li. That is mentioned right here. So there's the organolithium, which I could have made by just reacting the benzene with lithium and then the copper 1 iodide, and I get the Gilman reagent. All right, now that I have that, that's ready to be a nucleophile and attack the back side of something. I'm going to have a problem there. All right, so I need 3 carbons and an OH. Well, if I attack right now with this, I'm just going to do a backside attack to the OH because that's that nucleophile. So how about we start something with an OH on either end? Because if I did something like that, this can still do a backside attack to either end, causing that to get kicked off, and I still end up with what I need, which is a benzene ring connected to a carbon, 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 OH. Alright, that was a bit trickier than I'd like. Figuring out the right nucleophile there wasn't quite obvious. So let's try this the other way around, and what we're going to do instead is have this behave as the thing that does the attacking. Alright, that should actually be easier, because what I could do, I'm going to imagine this was a double bond at one point, and I'm going to start with an organocuprate that has the 3 carbons already on it, and I'll leave a double bond there just so I can eventually add an OH to it. Yeah, and then I'll have this attack my benzene with the bromine. So my backside attack now goes from that location, because it's near the copper lithium, to that point right there, giving me benzene connected to that CH2, which is a single bond to a CH, which is double bond to a CH2. Now I need to put an OH on there. I want to put it on the least substituted side. That was done with that BH3.THF along with basic hydrogen peroxide. That came out of our alkenes chapter, and I'm just going to go to the summary page of the alkenes chapter. So, table of contents. Let's see. Reactions of alkenes, summary reactions. There it is, the BH3THF and basic hydrogen peroxide. If you had a substituted alkene, you ended up having an OH on the least substituted side. So if we do that here, H goes to the least substituted side, or the more substituted side. OH goes to the least substituted side. All right, those are the two ways to do this where we're doing organometallics, just like first introduced here. So the benzene is either acting as the alkyl halide or the organometallic, the Gilman reagent. And one way is a little bit easier there, but they both involved a grabbing stuff from previous chapters. So up here I had to get a little bit creative with my nucleophile, and on this other one I had to go back to our alkenes reactions chapter to figure out what to do from there. All right, the last way that I wanted to show you involves this Heck reaction, which is a little bit more versatile for us because the halide is preferred to be a vinyl or benzene aryl halide, and then we're looking for something with a double bond with an H and a Z, and we'll keep that double bond. But the Z can be just about anything. So what I was able to do there, we have our benzene, and what we're going to react that with, and I can do that over here. What we're going to react that with is this guy, pretty much intact, except it's going to have a double bond, and then a CH2, and then that OH, just fully there. Oops, that's not an OH, is it? There's an OH. Now, as long as we do this with the palladium-based substituent or catalyst, the standard reagents for a Heck reaction, we end up putting those together. And for the most part, we're going to end up with a trans configuration along the double bond. So I have the double bond still here. Now just one CH, because we're going to lose one H with that when it bonds there. And I guess that's just a CH. But this will be trans because that's the nature of Heck reactions. They favor making trans. But that's okay. I don't really want that double bond anyway. So my last step here is just hydrogen with a platinum catalyst. Even though that gets rid of all double bonds, we'll find out later on it's harder to get rid of those double bonds in a benzene ring. I'll actually have to react that a lot more strongly later on to get rid of that. But getting rid of one that's even that benzylic position will be easier. We can get that same product, and that was just 2 steps. Heck reaction can be a heck of a lot easier. All right, number 6. We have ethanol, and we want to turn that into 1,2-butanol. All right, I need to add 2 carbons and an OH. Well, I know I can do that with an epoxide followed by just some water. And that could have been done to an organometallic with 2 carbons. And I'll do Gilman because it works a little bit better. Alright, so working backwards, if I just had 2 carbons as an organometallic and did the 2 carbons in OH, I'd end up with something like this, followed up with water. So I just need to turn this into copper lithium. Alright, I can't do that with an alcohol. So I'm going to back up to our alcohols chapter and turn this into an alkyl halide. And chlorine would be fine. And if I go to our alcohols chapter and the summary reactions, we have a few ways to do that. Now, if it had been tertiary or secondary, we can just do the acids, but this one was a primary. So I could use PCl3 with pyridine or the thionyl chloride. And I don't care. PCl3 has less characters. Alright, so I got an organo halide. Alright, I'm going to do this in 2 steps. That is lithium followed by copper 1 iodide to turn that into an organometallic, a Gilman reagent. Alright, so could have done that step with thionyl chloride. We probably could have done this just as a Grignard, so with the magnesium and ether, and probably even with lithium and hexane. So probably didn't need to do a Gilman, but Gilman's going to end up giving us slightly better results, and it's a little bit more stable. But the last step, that's the best way to put 2 carbons and an OH onto something. So epoxide followed by water would do a great job of that. Alright, how many signals in the proton spectra would we expect? Well, all of these CH3s are going to be very much very shielded, furthest down range. And then I have these. So I'd be expecting 2 signals.